Okay, I think everybody should be here now. I welcome everybody to this webinar about radial layouts. My name is Benjamin Niedermann. I'm a software developer and algorithms engineer at yWorks. So I daily work on layout algorithms, improving them, implementing new features, but I also think about new visualization techniques that you can use to visualize your connected data. Besides that, I also work or give this series of webinars in which I would like to introduce you to different layout algorithms and layout styles offered by yFiles, so the main product of yWorks. And today I would like to introduce you to a very specialized layout style, namely the radial layout. And during this webinar, I will explain how to use it, and I will explain when to use it. And also I will give some coding example where you can actually see how you can use the yFiles library to achieve or to visualize your data using the radial layout. So the main principle of, or the main idea of the radial layout is that we would like to visualize a hierarchy. Here in this example, a very simple example, is a directed tree. And the idea is that we create a hierarchical layout, but not a linear layout or where the nodes are placed in on horizontal lines, but on concentric circles, such that there's one node in the center of these concentric circles and all other nodes are assigned to the concentric circles around the center. And then the main idea is that the edges point outwards away from the center of the node. And this gives you a very simple way to visualize a hierarchy where you have one or maybe also multiple focus points in the middle, so that you can really express these are the important nodes, and then going outwards, the nodes may become less important. Of course, this is not only possible for trees. So in this example, I've just used a tree as a graph or as an example, but of course you can also use arbitrary graphs. In that case, the edges cannot only point away from the center, but there's maybe also edges that go along one concentric circle. So edges basically that connect nodes that belong to the same concentric circle, or there are some edges that point from one layer to another layer, but not in a radial fashion. So they do not directly point away from the center of this graph. Indeed, in our algorithms, we try to maximize the number of edges that point away from the center and minimize the edges that, for example, connect nodes on the same circle or nodes that are not aligned radially. In this webinar, I would like to show you how to use this radial layout. To that end, I would like to start with some examples, giving you some motivation where you can use it. And then after that, I will present the main principles that are important to know, especially if you want to configure these layout algorithms. And then I show you which kind of possibilities you have in practice, especially showing you the possibilities of the yFiles library. And then in the last part of this webinar, I will give you a short coding example where I actually show you how to use this layout using yFiles HTML. If you come from another platform like .NET or Java, this is no problem because the API is the very same. So you will also understand the yFiles HTML example and can then transfer this to your platform. In case that you have some questions, then please just let us know via the chat functionality of Zoom. A colleague of mine will collect these questions, and then I will try to answer them in the Q&A session after this webinar or after this main part of the webinar. In case that you watch this video on YouTube, because we also will upload this video to YouTube, then you can leave your questions just below the YouTube video in the comment section, and we will try to answer your questions as soon as possible. So let's start with the radial layout and with some examples where you can actually use this layout. And I would like to start with a very simple example, namely a social network where we would like to visualize the connections of a dedicated person to the other persons in this network. And what we would like to do is to express the topological distances. So this means that we would like to know to which of these people is this person directly or has directly a relationship, and where are there some indirected relationships. So what we do is we place this person in the center of this graph or of this layout, and then on the first concentric circle we place, for example, the friends, so the people with a direct relationship to this person, and then on the next circle we place the friends of the friends, and so on. And this gives us directly a nice overview of the relationship of this person to the other persons, and also gives us some information about the distance between this person to other persons with respect to the shown relationship. If you would like to try out this example, you can directly do this on our homepage. We have there set up a demo, and I also want to switch to this demo shortly. One moment. Like this. And in this demo, what you can see is the entire social network. And what you can do is you can click on one of these nodes, and then you get the relationships between these nodes and the direct friends. And this is done in a radial layout. And this is computed on the fly when I click on this node here. What you also can do is that you can increase the depth of this layout. So this basically means that you increase the number of hops that are displayed. So now we not only see the friends of this person, but maybe also the friends of the friends and the friends of the friends of the friends, and so on, depending on the depth that we choose here. And this is a quite nice way to visualize, for example, the neighborhood of a node. A very similar example is the reachability of airports. So assume that you would like to do a journey and you would like to start at the airport Frankfurt, which is a large airport in Germany. And you would like to know how many hops you need, so how many transfers you need to get to one of these airports here. And for example, from Frankfurt to Stockholm, you need to switch once, namely in Copenhagen. And here again, the circular layout gives you, the radial layout gives you a very simple possibility to express this information. Again, you have the main node in the center of the drawing, and then the less or the nodes with higher distance will also have a higher distance in this layout. In the coding example, I will actually use this example here, and I will show you how to configure this layout and also how to introduce more advanced concepts. Another completely different application are hierarchic clusters. So assume that you are given a set of cities and you compute the distances between the cities. And what you can do is you can cluster these cities with respect to their pairwise distances. So for example, New York and Washington, DC are close to each other, closer than to Montreal, for example. So this means that we introduce here some node, which I don't display at this point here. And then I connect these cities to this invisible node here, and I continue this approach. And this gives you a hierarchic cluster. And what you can do is, for example, you can use the hierarchic layout of yFiles to visualize this hierarchic cluster. So this layout has been created by the hierarchic layout. What you also could do is you can apply the radial layout on this. And using the dendrogram style, so then you get a radial dendrogram. And here the idea is that the nodes are pushed outwards as far as possible. So for example, here, this node could be also theoretically placed on this layer, but the dendrogram style says, okay, if it's possible to push outward this node, then I will do this as far as possible. And this gives you also a nice diagram showing the distances between these clusters. And what you also get is that here in this sequence, nodes or cities that lie closely together in real world are also placed closely together in this diagram. And since we have a radial layout, we can also use radial labels. So these labels all point away from the center of this diagram. And this gives us the possibility to make the diagram more compact, because now these labels are just in a line with these rays emanating from the center of this entire diagram. Another example of a hierarchical cluster comes from biology. Here it shows the terminology for feeding behavior. Again, we have 3 main clusters, and then we also have some subclusters, which are now also labeled and have their own nodes. And again, the leaf nodes are pushed outwards as far as possible. And such diagrams you often find in biology. Another example from biology is an even larger diagram, namely the tree of life. This you can also find on our homepage, and I also want to switch to this because here you can already see that it has a lot of nodes, and you really need to interactively explore this diagram to learn more about the tree of life. And what you can do is that you can now interactively explore the diagram. So what you can do is hover above these nodes and edges, and then what happens is that these single sectors here are highlighted, and you get also an enlarged labels. Of course, you can also zoom in and zoom out. This is computed in real time. And now we can also use this interactivity to, for example, to enlarge certain subtrees of this tree of life. So what I can do is I can click on this edge here, and then I get an only a subgraph or the visualization of the subgraph, again using the radial layout. And with this, I can explore the entire tree of life using a very nice interactive way. And with this, I can basically zoom into the data, filtering out and data that I'm not interested in. So this should give you some motivation when to use the radial layouts. And now I would like to explain you the main principles that are helpful to understand how to configure this layout. As I already said, the nodes are placed on concentric circles, and what we do is we assume that we are given a virtual tree. So basically, normally we are given an arbitrary graph that is not a tree, but what we do in the first step is that we compute a virtual tree. So basically a tree that decides which of the nodes should be in the center, and then based off this, we compute the edges such that they all point outwards, and then we are given this tree, and this is called a virtual tree. And basically the layout is created based on this virtual tree, and of course you can configure this, how this tree is actually computed. So with which strategies, basically the center node is chosen, and with which strategies the nodes are assigned to layers. So what we do is that we assign the nodes then to layers. So the first, the nodes with distance 1 to the center nodes are assigned to the layer 1, so to the first concentric circle, and so on. And these concentric circles are just called layers in the following. Another important term is the sector. So as we have a tree, we can define or find subtrees in this tree. So for example, we have here this subtree, and the sector is defined based on the nodes that lie most to the left most and to the right most here in this example, if we go from this point to this point, and this defines a wedge, and this wedge is called a sector. I explain this. This is because we use this to lay out this tree. What we do is that we have a rule, namely that we say, okay, the sector of a child node, for example, this sector, the sector of this node, should always be contained in the sector of its parent node. And this gives us directly a structure on the radial layout. And this is also why we call it a radial layout. This basically results in a layout where we point outwards from the center of the entire layout. And this rule is basically defined recursively. So the sector of this node here is again contained in the sector of this node, and because this sector is contained in this sector, we know that the smallest sector is also contained in the largest sector. The second rule that we have for radial layouts is that the sectors of independent subtrees do not overlap. And with this, we can guarantee that the nodes do not overlap. So I was a bit inaccurate when I created this drawing. Actually, the sector does not go here through the center of the node, but touches here the node. So we can really push these sectors together, and we can be sure that the nodes will not overlap. And this is what we use for the layout algorithms, but this is also what you can use to configure your layout, obtaining different, or tweaking your layout regarding distances. So for example. And this brings me already to the practice part, where I would like to show you what possibilities you have using the yFiles library. So which features we offer, and and which configuration possibilities you have using the yFiles library. I would like to start with one topic, namely the center nodes. So of course, this is an important question: which of the nodes should be placed in the center? And of course, you can just specify this by your own. And what you can do is you can specify a single node and say, okay, this dark blue node, for example, should be placed in the center of the drawing. But what you also can do is you can place multiple nodes in the center of the drawing. In that case, it's not a single point where the nodes are placed, but they will be placed on the innermost concentric circle. If you don't want to do this automatically on your own, then you can also do this automatically. So for example, you can use the centrality measure, which basically, or roughly speaking, measures the or finds a node that lies in the center of the graph, and then we use this node as the center of the graph of the layout. So the centrality is a very typical graph measure, and it basically gives you the center, or somehow finds you the center of the graph, and this lends itself to use it for the radial layout. Another possibility is to use the directedness of the edges, so that you try to find a node where many edges point away. In the case of a directed tree, this is easy, so there you only need to find the root. But for an arbitrary graph, we apply some heuristics, finding the best node for this case. You don't need to think about how to do this algorithmically, but you can define this on your own when you configure the layout, which of these strategies should be used. Apart from the center node, it's also, of course, important to say how the nodes are assigned to layers. This is there are different possibilities, and of course, you have the possibility to use to do this in a user-specified way. In the coding example, I will show how to do this. Here I extended the example where I also introduced some distances, and I then assigned the airports to different distances, such that we get here some layers. So in this case, the layering is not automatically computed but I have written some custom code that computed this layering. With the layering, I really only mean that you assign the number of the layers to the node, so that you say, okay, the first or this node should be placed on the first layer, this on the second layer, this on the third layer, and so on. But the remaining computation is completely done by our algorithms then. If you don't want to specify them on your own, you can also use automatic approaches. And here's, I just give two examples, namely the breadth first search, which is a typical way to find a layering in a graph. So basically what I do is I start with a center node, and then I go to all its neighbors and they get the first layer. And then I go to the neighbors of this node, for example, and if they haven't assigned to layers yet, then they get the layer that is still free. So for example, this node then gets the layer 2, and so on. Another way is the dendrogram style, where I also first compute a layering, but in that case, I also place the nodes as far as possible outwards. So basically, if it's possible, I place them on the outermost circle. So for example, this node is placed on this layer and not on this layer. Also, this would be possible. And this is the so-called dendrogram style. Apart from that, you can also customize the edge routing style. So for example, you can use curved edge routings or polyline edge routings, and you can also use polyline radial edge routing, which is a quite new feature. Here the idea is that if this is the center node, all edges point away from the center, but if they need to go through or if there is not a direct way, then they may also use the circular arcs of the concentric circles. And then finally, there's also the possibility to define arcs. Then I already showed you this in one of the examples, that it's sometimes nice to have radial labels. Here in this case, you can say, okay, I use horizontal labels. So you just define them as horizontal, and then all labels are placed horizontally. This is normally useful if the nodes are a bit larger, so they can basically contain the label. This is not the case in this example. In this case, I would recommend to use radial or ray-like leaf label or ray-like labels. For ray-like leaf labels, the idea is that the leaf nodes of this virtual tree get radial labels, and radial labels means that they point towards the center of the drawing. And then the ray-like labels here, every label points to the center of the drawing, a part of the label of the center node, of course, because here we cannot say which of the node or where the node label should point to. And then finally, I also would like to mention the distances that you can use to define or to customize your layout. Of course, there are some minimum node-to-node distances. Here, the minimum node-to-node distance refers to the distance between nodes on a common concentric circle. Then you can also define the minimum layer distance. So here you can say, okay, that the distance between these two layers should be at least a certain number of pixels, and then this is enforced for every of these layers. And then there's also the sector distance. Here the idea is that the distance between the sectors is is enforced between the outermost nodes in these sectors. And this gives you the possibility to also say, okay, that there are some kind of gaps between these sectors. Okay. This part of the webinar has been recorded after the actual webinar took place. The reason is that we faced some technical issues, and therefore we had to record this part again. In this part, I will give you a coding example showing you how to configure the radial layout using yFiles HTML. If you come from other platforms like Java or from .NET, you can also use this example basically because the API of yFiles is the very same also on the other platforms. The idea of this coding example is that we are given some airports, and so as a JSON file, and each airport represents a node. So it has some name, but it also has some coordinates given in longitude and latitude. And then we also have some connections between these airports, describing how we can get from one airport to another airport. And the idea is that we would like to visualize the reachability of the airports starting at Frankfurt, so a large airport in Germany. And then based on this, I want to show you how to create a radial layout. And in the first part of this coding example, I will show you how to do this with a basic setup, just using an automatic layering strategy. And then in the second part, I will give you also an example for a more advanced setup, where it's also about how to customize the layer assignment of the nodes. So now I will go to the source code and show you how to configure the example or yFiles HTML for the example. What we have is here this method create layout basic. This is called when the layout is created, and as you see, this method is still empty. And this is also the reason why all nodes are placed on top of each other. We haven't applied any layout yet, and now what I do is I create a radial layout. And I just do it like this, and then I run this layout on the graph using apply layout. And when now I reload this example, what I get is this radial layout. So this is a very basic configuration for this, but already we have a nice assignment, and the layout algorithm automatically detected that Frankfurt should be the center node of the graph. But of course, there are still some things that we can improve on. So for example, there are still overlaps, and the layers are very close together. And now I want to show you how to solve these problems. That the labels overlap is because we haven't told the layout algorithm that it should consider node labels. And we can basically do this by just setting a flag, namely consider node labels to true. And what now happens is that the entire layout becomes a bit larger. This is because the nodes now need more space for the node labels to fit in. And this means that, this also impacts the radii of the concentric circles where the nodes are placed on. What we also can do if we still are not happy with the distances between the layers and we would like to increase them, we can also do this using the minimum layer distance, for example. I just do it here with a high number to illustrate this. So let's say 500 pixels. And then the distances become even a bit larger, but I would like to have a more compact layout, and therefore I just use the default value. What I also can do is that I can define the routing strategy of the edges. So currently we use here these curved or polyline edge routing, and I would like to use this where we only use circular arcs and rays emanating from the center of the nodes from the drawing. And to that end, I define here the edge routing strategy as a radial polyline, which is a quite nice routing strategy. And now we get this layout where each edge consists of segments pointing to the center or of circular arcs, part of concentric circles around Frankfurt. So next, I also would like to change the labeling a bit. So what I would like to have is to have radial labels, so that all labels point towards the airport Frankfurt. And to that end, I can tell the algorithm that it should use integrated node labeling. To that end, I set this to true, this property, and then I can also set the labeling policy, namely to ray-like. And when I now execute this, you will notice that the labels do not point to the center of the drawing. I just execute this once. And the reason is that there is still a label model attached to the graph that is not supported by the integrated labeling. But we need to tell the, or we need to attach a labeling model to the labels that can be used also by the layout algorithm. And to that end, I need to define a new label model, go through all labels and assign this label model basically to these labels. If you want to know more about label models and how they work and how you can configure them, then I recommend you the YouTube video about edge and node annotations that that has also been recorded in the series of webinars. So let's change the label model. We have to that end, I define a new label model, namely the free node label model. And this basically tells the algorithm, okay, it can move the labels everywhere it wants, and it can also rotate the labels. And then I go through all labels of the graph and tell the graph that it should use the given label model for this label that I have in my hand. And to that end, I define this layout parameter, and for the free node label model, I can just use the default parameter. And when I now execute this, all labels point towards the center of the drawing, a part of course of the label of Frankfurt, which is placed above the node. Of course, sometimes it's nice also to place this label maybe not on the top of the node, but somewhere else. And what you then can do is you can change the label layout parameter for this particular node so that you enforce a different position for this node. But for this example, I just use this basic setup. Another thing that you sometimes want to do is to actually specify the center node. So as I have created this data basically for the airport Frankfurt, this is a directed tree that starts at Frankfurt and all edges point outwards. So the algorithm has no problem to identify the center. But sometimes you would like to customize the choice of the center, and you can do this as follows. For that, to that end, you need to define a layout data. And I directly append this layout data to the layout process. And what I can do on the layout data is that I define the center nodes via a delegate. And the idea of this delegate is a lambda function that returns true for a given node if it is a center node and false otherwise. So what I can do is, for example, that I say, okay, I check whether the name of the node, which is stored in the tag, is, for example, let's say London. And if this is the case, the method returns true and otherwise false. And this changes the center node. I forgot one thing, namely we also need to tell the algorithm that it should consider a custom center node. To that end, we need to define center nodes policy, and this should be a custom. As I said in the webinar before, you can also use different strategies. As you can see, now the layout becomes a bit imbalanced. This is because I have computed the data basically for the airport Frankfurt and not for London, but it show you in principle how to change the center node. Of course, you can also define multiple center nodes. So to that end, what you can do is that you create an array of possible center nodes, or of the nodes that should be the center nodes. This is, for example, Frankfurt and London. And what we do is we check whether the given node has the label either Frankfurt or London. And to that end, I also introduce a further lambda function and check whether this is the city label. And now I apply again this algorithm, and what you now can see is that both airports are placed on the innermost concentric circle, so that they become both same important for the layout. As I already said, the data is meant for one single airport, namely for Frankfurt. This is the reason why it now becomes a bit imbalanced. But it shows you how to change the center nodes in principle. Next, I would like to go to the second part of this coding example and show you how to do a more advanced setup where you define your own layers. And to that end, what we do is, or the basic idea is that we have some kind of distance zones assigning the airports to certain distances. So going back to the source code, I can switch the example here using this flag. And I just will go through the source code. So I've already prepared the configuration, but I first want to show you the basic idea of this example. So here again, we have this airport, and now we have distance zones. So we have airports that have a distance between 500 and 1,000 kilometers, then between 1,000 and 5,000 kilometers, and so on. And within these distance zones, we sort them using the number of hops that we need to get there. And this is then the layering information. Besides that, I also do a very simple but common trick. I also extend the graph by the legend that I use. So for example, this node or this label here is also an actual node in the graph. And this polyline here is also an edge in the graph. And this gives me the possibility to introduce this path here such that the layout algorithm also takes this path into account. And now the idea is, or the question is, how can we configure the layout algorithm that it takes these zones also into account? What I do is basically I define again here in Radial Layout, and I tell the layout algorithm that the layering strategy should be user defined. And then I also define a radial layout data and define the layer IDs for each node. So basically for each node, I tell the algorithm on which layer it should lie. And basically what you can do is you can just give an ordering of the node. So you can say, okay, I assign a node a larger number than another node in order to express that it should be placed on a circle that lies more outer than the other node. Here, for that end, I have written function get layer of node. I will later on explain how this works. But this line basically defines which node should be placed on which layer. And then I apply this layout, and then these nodes will be assigned to these layers. But for this example, I'm also interested in this information on which particular layer and which radius this particular layer has created by this layout algorithm. And to that end, I can also attach this dictionary to this layout data using this property node infos. And the layout algorithm then will fill this dictionary. So basically what it does, it creates for each node a radial layout node info and will attach this to the node. And then after applying this layout algorithm, I go through all nodes and then create the zones. And what I do is that I only consider the nodes that are legend nodes. So for example, this node or this node. And for each of these nodes, I create a circle having the radius of the layer assigned to this node here, for example. So here, what I do, I take the node info and I take the radius of this node info for this legend. And then I have here this method create zone, which basically adds a circle to the background layer having this radius. So then it remains to explain how to get to write this get layer of node, and this is a very technical problem. So I decided to explain this on the slides. And I only will do this with a small example of using some of the airports. So with a subset of these airports. And the idea is that in the first step, we assign these airports to buckets describing these distance zones. So for example, Frankfurt becomes is assigned to the first bucket, Moscow to the next bucket, and so on. And this gives us zone 1, zone 2, zone 3, and zone 4. And then this already gives us a certain kind of layering structure. But then we also need to order these nodes within the layers, and to that end we take the graph information. So we create for each of these buckets a small graph. So for the first two buckets, it's a very small graph consisting only of two nodes, namely basically the legend node or the node representing the zone. And then for the other graphs, we get these edges based on the information that we have taken from the data. So we know that from Hong Kong to Bangkok, there's a connection, so we introduce an edge here. And in the next step, we do a first search on these small graphs, starting from the left to right. And assign the layers to this. So here I start with 0 and 1. And then for the next search, I start with a layer +1 with respect to the previous subgraph. So here the node gets the layer 2 and the layer 3 and so on. So this node gets the layer 4, 5, and here again 5, so they belong to the same layer, and the next node needs to lie on the next layer to node 6. And this gives me a total ordering of these nodes from which I can derive the layering. And this is how the get layer of node works, this method. So this is the rough description of this. And with this, I already want to finish with the coding example and also wrap up the webinar with the conclusion part. And what you have seen in this webinar is a very specialized layout, namely a layout that places the nodes on concentric circles such that there are some or few nodes in the middle of the layout which are really important. And then you have some hierarchy that goes outwards. And with this, you can express distances, so for example, topological distances, but you can also express clusters very nicely. And this gives you a possibility to especially visualize tree structures, but also tree-like graphs. So if there are not too many non-tree edges, we can also reroute the edges through the layers easily. In the next upcoming yFiles version this year, there will be also 2 new features, namely node types and custom orderings of child nodes. So here the idea is that you can customize the order in which the child nodes of another node appear on the layering, which gives you even more possibilities to customize the layer. And with this, I would like to wrap up the webinar, and I wish you happy diagramming.